In 1783, the first hot air balloon was launched by the Montgolfier brothers into the air for 8 minutes, carrying 3 animals. With constant improvements for more stability and to travel to higher altitudes, today the hot air balloon has become a wonderful recreational activity that millions strive to experience. Though it may not be the fastest means of transportation and appears to be quite easy to navigate, the ingenious art of hot air ballooning incorporates several basic concepts of chemistry. Whether it has to do with setting up the balloon, piloting it, or even the material used to construct it, chemistry is utilized. First, in order to understand the chemistry behind hot air ballooning, it is important to know the different parts of a hot air balloon. Every hot air balloon has an envelope, fuel tanks, and a basket. The envelope, which most spectators pay attention to, is where the air is heated. In the past, envelopes were made from silk. However, today they are mainly made from ripstone nylon or polyester. These lighter and stronger materials allow for more durability and can survive higher temperatures. As well, these types of materials are highly resistant to many unwanted natural effects such as mold and fungi. On a side note, nylon is a polymer made up of atoms into a chain of molecules. Made from carbon-based chemicals, since nylon does not exist in nature, 2 large molecules are heated in an autoclave. This process is called condensation polymerization, named accordingly since there is a formation of large molecules and the disappearance of water. Thus, this chemical process results in sheets of nylon that are shredded into a yarn-like substance that is used in everyday products such as the material used for a hot air balloon envelope. Also, the envelopes are often cut into panels and sewn together called gore sections. The various seams involved consist of rows of stitching and are mainly in zigzag formation. Coated usually with polyurethane, the fabric becomes more impermeable. Specifically, the hydrogen bonds within the urethane group form the resistant properties, which in other words means the envelopes are more scratch resistant. In addition, at the top of the envelope there is a valve. This is where the hot air from the balloon can be released when the pilot begins to land the balloon. Another part of the hot air balloon is the fuel tanks. This is where the fuel for the balloon is located. Now, in modern balloons, most pilots use propane for their fuel. Propane is usually stored in liquid form in lightweight cylinders. When the pilot goes to burn the fuel, the liquid flows through the hoses to the burner, and once heated, propane turns to gas and is considered a powerful and efficient type of fuel. Lastly, in order to hold the fuel tanks and passengers, all hot air balloons are equipped with baskets, commonly known as gondolas. They are made of woven wicker and rattan, which is proven to be both durable and lightweight. As well, they are more flexible, which helps absorb some of the energy when the balloons land. Now that you know how a hot air balloon is constructed and what materials are used to do so, it is time to understand how basic chemistry is applied when it comes to flying a hot air balloon. Many spectators find that the actual setup and launch of a hot air balloon, which takes all of 15 minutes, is far more enticing than the ride itself. Starting with the deflated balloon, crew members turn on a fan to fill the balloon with air. They make sure the valve at the top of the balloon is closed, and once there is enough air inside the balloon, the air is heated with a flame. Now, when the air inside of the balloon is heated and temperature increases, according to the ideal gas law, the pressure inside the balloon increases as well, thus inflating the entire balloon. Then, once the hot air balloon is ready to be launched, more heat is added to the balloon to lift it, and since hot air is less dense than cold air, it rises. Now, density is how much mass there is in a given volume. Thus, when the air, which is in a gaseous state, is heated up, it expands due to the fact that its molecules begin to have more energy and are moving faster. As a result, when the rate of collisions and force at which the molecules collide increases, there is less mass in the given amount of volume inside the balloon. Therefore, in order to better understand how a hot air balloon rises, we decided to conduct an experiment where we built a candle-powered hot air balloon. First, by starting with a plastic bag with the handles cut off, wooden splints to make a base for the hot air balloon, candles as our source of fuel, 4 12-inch strings, and a cardboard-made candle holder, we began assembling our version of a hot air balloon. First, we made a 10-inch by 10-inch square using the splints. Then we tied the 4 strings to the candle holder. Next, we taped the square to the bag to keep it open and placed the candles in the candle holder. Then we attached the other end of the strings to the other corner of the plastic bag. Finally, we lit the candles and waited for the air inside the bag to heat up. Then, after a while, and after burning the bag a little, we were successful at having our hot air balloon rise when heat was added, just as a regular hot air balloon would rise. It's also interesting to see how a hot air balloon remains in the air and travels. Since gravity is always pushing down on objects that are off the ground, it is puzzling as to how a balloon stays up in the air and does not sink. This is due to the fact that buoyancy allows the balloon to float in the air, similar to how a boat floats in the water. Buoyancy is the upward force that an object feels, and this force is equal to the amount of volume displaced by that particular object. Though this phenomenon is mostly physics, it is very well links with chemistry too. As a hot air balloon travels to higher altitudes, the air pressure decreases, thus there are more particles below the balloon pushing it upwards. However, the buoyant force is weak compared to gravity, and there is an upper altitude limit when the air becomes too thin that the buoyant force is too weak to lift the balloon. Therefore, in order to fix this problem, pilots lower the air density inside the balloon by once again reheating the air. This then decreases the mass or weight inside the balloons, hence making it lighter, but at the same time keeps the air pressure constant inside the balloon. So, in order to better understand this concept of buoyancy, an experiment was conducted by a professor where he showed that the more volume of air displaced by a balloon, the stronger the buoyant force. However, in his demonstration, he uses helium instead of regular gas. Let's take a look.
Deal with that for some of these demos, but okay. And it's been weighted here to make it just a little bit more dense. Can you all see that? I've also let some of the helium out. The way you do that, by the way, there's a little sleeve there, and you can just stick like a plastic straw up in that sleeve, and once you get, it's like a sleeve, and once you get past the end of that, you can just squeeze it out, and then take the thing out, and it seals itself. So you could do it again if you want to put some more in, or that's how they fill them, and that's how they can empty them too. So I need a little bit of heat for this, and I'd use a Bunsen burner, or you could use a hot plate. And again, this is helium, not hydrogen, okay? All the same, though, I'm going to be putting it, wow, there's quite a, okay, right about here. If I can put my hand there, it's going to be okay putting the balloon there. And the idea is just to warm it up some. And, oh boy, okay. You see it start to puff out then, yeah? As though I'm putting more in, but of course I'm not putting more in. Okay? And now that same balloon that was more dense is now magically less dense. How am I going to get that?
Lastly, you may be wondering, can hot air balloons only move up and down? How do they move left and right? Well,
the only way to steer a balloon is to use the wind. The wind's direction changes between altitudes, so you move up and down to go left and right. When you want to go up, you provide more heat. When you want to go down, you open a hatch in the side of the balloon that releases hot air. You can't really tell exactly where you're going to land. That's why most pilots have co-pilots on the ground to follow them.
So, in order to simulate how a hot air balloon is piloted, we conducted a second experiment as well. We used the same materials as the previous experiment, except instead of using candles, we used a hairdryer with hot and cold settings. So, when the cold air switch was turned on, the hot air balloon, which once again was represented by a plastic bag, struggled to rise. However, once the hot air switch was turned on, the plastic bag rose. Thus, we were able to simulate how pilots increase and decrease the temperatures in hot air balloons to navigate up and down to desired altitudes. So there you have it. Though hot air ballooning is considered a serene and calming activity, it is evident that the process involves great care and thought. By incorporating several basic principles of chemistry, the hot air balloon has evolved into a safe and enjoyable experience for all, and a great scientific accomplishment.